Welcome back. Today we're going to look at topological sort. We're going to see what topological sorting is, what it is used in real life, and we also look at a code example on how we can implement it. But first, what is topological sorting? So topological sorting is a way to order tasks such that each task appears before the task that depends on it. So think of it, an example is maybe you're making breakfast. So when you're making breakfast, the first thing you do is you need to toast your bread before adding butter. If you're trying to make coffee, you need to brew your coffee before you pour it into a cup. The key rule here is that if task B depends on task A, then task A must come before task B. So that is basically the key role in topological sorting. A real life example that we can use to think of this is, for example, in project management, right? So imagine the project development process and you have a number of tasks. So let's say this is our first task here, second task, third task, all through. Now, what you do with topological sort in such a case is, or rather how it works in terms of the steps. The first step that we're going to take in our process is we're going to design the project that we're working on first, right? So let's say this is the design, this is the design step. Then the second step is the coding phase. So we code that project. We go ahead and test the project afterwards. And then finally, we're going to go and deploy this project. So deployment comes last in the project development process. How we can visualize this basically is we have designing coming first, then we have coding second, we're going to have testing, and we're going to finally have deployment. Now, the challenge here is how do you figure out the correct order of tasks when several tasks depend on each other? So, how do you figure the correct task? I mean, the correct order. And this is where topological sorting comes in and helps a lot. What it does is basically it gives us a sequence where each task appears before its dependent tasks. Now, the approach that the topological sorting takes is it follows the DFS to explore a graph. So by DFS, I mean here it follows depth first search to explore a graph. Then, as we visit each node in the task, we're going to add it to a stack. So think of it like this is a graph that we have here. Then we have multiple nodes around. So as we visit each node or each task, we're going to add it to a stack. So let's say we have a stack here where we're basically adding the tasks. So let's say we explore this task, we go ahead and add it to our stack. Once we are done processing all its dependencies, basically, so at the end, the order in the reversed stack is the one that is going to give us the correct topological order. So again, remember, as we're adding these tasks, the first task that we add goes there, second task, third task, until you have the last task here. So at the end now, the order in the reversed stack, once we reverse this stack now, that is going to be the correct topological order. Now that we've seen ideally how this is going to work, so an example, this is also an example of how tasks are. So in this case, these tasks are not ordered by, and so that you can understand which comes first and what comes when, because each of them depends on the other. So for example, task 3 depends on task 1. Task 2 depends on task 1 and task 3. And then we have task 4, which depends on task 3 and task 2 as well. So in such a case, we have to order these tasks in a way that each task comes basically the dependence the way they follow. So let's say we can maybe have the task like this. So in these are maybe the nodes that we have of all the tasks. So here we have one, then we have two here, we're going to have three there, and finally four here, right? Now, it doesn't mean that one is directly to two like this. It could be that in this case, three depends on one, right? So this goes like this. So three depends on one. As you can see, the way the order is following, basically, it's following the topological order in that basically each task depends on the basically each task appears before the task that depends on it, right? Then we go ahead, let's say 2, 2, and 2 and 4. It could be something like this. Then and the process continues. So we're going to do this kind of ordering in our example, and that is what topological sorting is. Now let's go ahead and write some Python code on how we can do this. So first, we're going to define a function, and we'll call this function topological sort. And this topological sort function is going to take in a parameter, and the parameter it takes in is a graph. So the graph that we're trying to go through. The first thing we need to do is we need to track the visited nodes. So we're going to create a set for that, and we call that a set visited. This is for tracking the visited nodes. Then we're going to go ahead and store the nodes in order. So in such a case, like you mentioned in the explanation, we're going to use a stack. So here we're going to have a stack where we're storing the nodes in order. Then the next thing we need to do is now create a helper function for depth first search. So in that, we can just create a function. Let's call it DFS. Then it takes in a node, and we're going to just check if the nodes are visited or not. So we say if node not in visited, the node is not in visited, we're going to mark the node as visited. So how we do that, we just say visited dot add, then we add the node like that. So that way we mark the node as visited, and then we're going to go ahead and explore the dependencies. So to explore the dependencies, we just use a for loop. We can just say for neighbor, for neighbor in graph. Then so we specify the node. So for neighbor in graph, this is exploring all the dependencies. We just go call our DFS function here, and we pass in the neighbor node like that. Now the next thing we're going to go ahead do after this is adding the node to the stack after visiting all their neighbors. Again, we need the stack so that we can track the order that is. So in this case, we just do stack.append. Stack.append, and we're going to append the node like that. So now after that, the next thing we're going to go and do is apply DFS to every node in the graph, since we've already ascertained everything and how it works. So to apply DFS to every node in the graph, we just need to iterate through the graph. So we'll just say for node in graph, then we just basically apply DFS on them. So we just call the DFS function on each of the nodes. We call the DFS function on each of the nodes like that. Then finally, we just reverse the stack so that we can get the correct order. Remember, after reversing the stack is when we get the correct order. That is the topological order now that we want. So in this case, we just need to return. The stack, and we're going to just reverse it. So to reverse, just do this. Okay, so now that we've reversed the stack and to get the correct order, we can test this out and see whether it works. So to test it out, we need a graph. So we need a graph, and actually, I think we had a graph from the last example that we looked at. We looked at the Dijkstra's. So let me do this. When you looked at Dijkstra's algorithm, we use this graph here. So we'll just have it instead of having to repeat. So we have, but now we'll change a few things here. For the nodes, we're going to have node B and C here for A. Okay. Then here we only have C. Then we need D. So we'll just have D here. And then we also have D down here as well. Right. So this is the first one is A, which must happen before B and C. Again, this order that I'm following here is the same order that we have from the simple graph that we have here. So think of this one as this is A, B, C, and D. So here A must happen before B and C, B must happen before D, C must happen before D, and D has no dependencies. So if you look at this, D has no dependencies basically. So after getting this graph, we'll just run the topological sort and print the order, and ensuring that we get the correct order. So we can just print, and then we call the topological sort function and pass in the graph that we just created. Now, if we go ahead and run our code, say Python 3 topological sort.py, as you can see, we've gotten the correct order. Again, this order came after it has been reversed. But yeah, that is the correct order. And basically, what you've done up to this point, we started by creating a set where we add after we visit each node, we add it to the set, then a stack for tracking the order. Then we do DFS on the graph, then check if a node is not visited, we add it to the we add it to the visited set. Then we explore the neighbors of that. Then we also go ahead and append those nodes. Then we apply now DFS on all the nodes in the graph. After it has done everything, we reverse the stack. And then after reversing the stack, we get the correct topological order, which you've gotten here. And that is basically it on topological sort. And there are a number of applications of this, which is, for example, in task scheduling systems, we find that topological sorting could be used. And yeah, I'll see you in the next one. Thank you for watching this far.